In this video, I will be showing you guys a few examples that involves solving exponential equations. Okay, so here they want us to solve 3 to the power of x minus 1 equals 3 to the power of 5x. They want us to solve that. In other words, we need to find the value of x so that this will be true. Okay, so when they say solve, that means find the value of the variable, find the value of, in this case, x, find the value of x so that the equation is true. So that the equation is true. So just find x, right? Just find x. Alright, cool. Now, before I start with this, I'm actually gonna show you guys an even easier example. Let's say today I have 2 to the power of something is equal to, say, 8. Okay? And I need to solve that. So in other words, 2 to the power of what gives us 8? So I can say 2 to the, so maybe some of you guys might be able to say, okay, easy, x is equal to 3. Right? X equals to 3 because 2 to the power of 3 gives us 8. That's correct. But you know, it's always good to know how to get the steps to get that answer. So I'm going to say 2 to the power of x. I don't know what that is yet, but I'm going to try to change 8 to have the common base. So 8 is equal to 2 to the power of 3. So now that the bases are the same, all I have to do is to match the exponents. So which means my x must be equal to 3. Alright? So I'm going to apply the same logic to this question here. So let's get started then. So I have 3 to the power of x minus 1 is equal to 3 to the power of 5x. Now the bases are the same, which means all I have to do is to worry about the exponents. Right? I just have to worry about the exponents. So x minus 1 must be equal to 5x. And I can just combine like terms. And I can solve for x. So my x is equal to negative 1/4. And if I substitute this in my equation, I'll get 3 to the power of negative 1/4 minus 1. And we'll see if this is true, that this is going to be the same as 3 to the power of 5 multiplied by negative 1/4. Let's see. So, and we'll see if this is true. Right? So negative 1/4 minus 1, that gives me negative 1/4 minus 4 over 4. And that gives us 3 to the power of negative 5 over 4. Okay, so that's the left hand side. This is my left hand side. Okay? My right hand side, which is over here, that would be 3 to the power of 5 multiplied by negative 1/4. That gives me negative 5 over 4. So as we can see, the answers do match. So the left hand side is equal to the right hand side. So when my x is negative 1/4, my equation is true. I'm able to satisfy the equation. Okay, let's look at the next example. So in this one, this is a bit harder because the bases are not the same, right? If you take a look at this, the bases are not the same, so we cannot just, we cannot do what we did in the first example where we can just kind of connect the exponents, right? So what do we do here then? We'll try to force it the same. Okay, so for this one, it's a bit different because the bases are the same, our bases are not the same. So why don't we try to make them the same base? So the left hand side, I won't change anything, but the 81, I'll change that to a base of 3. So 3 to the power of something gives us 81. That would be 4, right? 3 to the power of 4. 3 times 3, that gives us 9. Times 3 times 3, that gives us 9 times 9, which is 81, right? So that's good. Alright, so 3 to the power of 4 gives us 81. Now that the bases are the same, I only have to worry about the exponents. Right? In order for them to be equal, 3x plus 1 must be equal to 4. and the rest is just algebra. So x is equal to 1. Alright, so if you want to check your value, if you put the 1, if you substitute the 1 back into the original equation, then I get 3 to the power of 3 times 1 plus 1. That gives me, is this equal to 81? Let's see. So this is 3 to the power of 3 times 1 gives us 1, plus 1 gives us 4. So 3 to the power of 4 is 81. So that's good. So which most likely your x is going to be 1. So overall, we're just trying to make the base the same. And then all we have to do after that is to compare the exponents. Last example. Okay, so this is different, right? This is different because what we had previously, it's a number as the base, another number as the base, but now this one that we have, this is different. We have x over here, but so what, right? So what? It doesn't matter. We'll deal with the x later on. But for now, can we try to somehow remove the 3 in the front? This is 3 multiplying x to the power of negative 3 over 5. So I can remove the 3 by dividing by 3 both sides. So that cuts out. And I'll get x to the power of negative 3 over 5. To the, this is equal to 8. Okay, now, what else can we do? Can we change 8 to become x to the power of something? Can I do that? Because previously we have tried to make the bases the same, but this is not going to work anymore because x is something that I need to find, and this is simply not possible, right? So I'm not going to mess around with the base. Then is there maybe a way for me to mess around with this exponent? Maybe. Let's see. So my goal in the end is to get x is equal to blah blah blah, and the x over here would have a power of 1, right? So my goal in the end to get is to find x is equal to something, right? And that x would have a power of 1. So is there, I guess what we'll try to do now is to try to convert this into that. Okay, that's what we're gonna do. And how do we do that then? Why don't we try to, the whole left, the entire left hand side, I'm gonna say, okay, I'm gonna have you to a power of 5 over 3 and then a negative as well. If I do that to the left, I need to do the same thing to the right. That makes sense? You might be asking, why am I forcing a power, the exponent, this exponent, to, I already have exponent and now I'm going to introduce another exponent. Isn't that going to make everything even more ugly or even worse? But if you think about it, power to the power, let's say if I have a to the power of, let's say 2 to the power of 3, the whole thing to the power of 4, that becomes 2 to the power of 3 times 4, which is 2 to the power of 12, right? We reviewed on this with the worksheet that I gave you guys, and I'm gonna use this property, power to the power. We multiply the exponents. I'm gonna use that property. If you see here, if I multiply them, negative 3 over 5 multiplied by negative 5 over 3, I would get the 5 and the 5 cancels out, the 3 and the 3 cancels out, and negative times negative, I would get 1. And that's good because that's my 1 over here. You see that? This one is my 1 over here, right? So if I do this, I'll have x equals, now I only have to figure out what's 8 to the power of negative 5 over 3. And that's not too bad because my base is 8. So that this is better than having an exponent for my variable, right? So let's try to solve this 8 to the power of negative 5 over 3. So I want you guys to pause the video and see if you can solve this 8 to the power of negative 5 over 3, all right? Okay, welcome back. So now I'm gonna try to break 8 with a base of 2 to the power of 3. That gives me my 8, and the negative 5 over 3 will still be there. And again, I'm gonna introduce power to the power. I multiply them, so I'll have 2 to the power of, so 3 times negative 5 over 3. The 3 and the 3 goes out, I get negative 5. Right? 2 to the power of negative 5. And this is not too bad now. This becomes the negative, becomes a reciprocal. 2 to the power of 5, 2 times 2 times 2 times 2. That gives us, this is 4, 4, 2, 16 times 2, so I will have 32. And that's my x. Alright? Okay, so I guess the overall big picture wise is to use the rules that we learned from our previous math classes, the laws of exponents, to help us to get this power of 1 that we are hoping to get. So power to the power, we multiply them. So when you are assigning this extra power, when we were introducing this extra exponent, this extra bit there, we have to be very strategic. Okay, we have to be a little bit smart with the exponents that we're introducing. All right, this is it for the video, and I will see you guys. Bye bye.